In this video we will be learning about super and zip function. So super function is a built-in function which returns a proxy object that is a temporary object of the superclass that allows us to access method of the base class. So let's create a class named mammal. Okay, and let's put object as the argument. Okay, so here we are going to define a init method and we'll put self and mammal name as arguments. So here we are going to print the mammal name and is a warm blooded animal. Okay, and let's create a dog class, dog. Okay, and let's put mammal as the argument, and here also we will make a init method. Self will be the argument, so we will print here dog has 4 legs. Okay, and we'll call the super. Okay, dot init and we'll put dog. Okay, let's make a d1 variable and call dog. Okay, so let's run the program. So you can see here dog has 4 legs and dog is a warm-blooded animal. So here we call the init method of the mammal class using super dog init dog instead of mammal.init. Since we do not need to specify the name of the base class when we call its member, we can easily change the base class name. Okay, so now let's see about the zip function. So our zip function takes iterable 0 or more and then aggregates them into a tuple and return it. So let's make a list of number, let's say number underscore list. Okay, and I'm going to store 1 2 3 inside it, and let's make a string underscore list here, and we'll be storing the same in string 1 2 and 3. Okay, so let's take zip without any iterable, so let's make result equals zip. Okay, so let's convert it to a list. Result underscore list equals list of result. So let's print the result list. So you can see here an empty list. So let's take 2 iterables here. Result equals a zip of, let's take number list and str underscore list. Okay, and let's convert this into a set. Result underscore set, okay, equals set of result. Let's print the result underscore set. Okay, so you can see the output. So let's take different number of iterable elements now. So let me make a numbers list and let's show 1 2 3. Okay, and let's make a str underscore list also. This time we will take 1 and 2. Okay, and now let's take a numbers underscore tuple. Okay, so we'll store inside this, let's say 1 2 3 and 4. Okay, so now let's make the result variable and call the zip numbers list okay, and our number tuple, okay. So let's convert it to a set equals set of result, okay. And then we'll print the result underscore set. So you can see the output here, okay. So let's make a variable result equals zip of our number list, okay, and our str underscore list and our numbers tuple, okay. So let's convert it to a set result underscore set equals set of result. Let's print the result underscore set. So you can see the output 1 1 1 and 2 2 2, okay. So the star operator can be used in conjunction with zip to unzip the list, okay. So let's unzip it, unzip, okay. So let's make a coordinate variable and let me put x, y and z inside it, okay, and the value variable, and let's store 3 4 and 5. So I'm making a result variable and we call zip of coordinate, okay, and value. So let's make a result underscore list variable and we'll convert it to list result, okay. Let's print the result underscore list, okay. So you can see here the output. Similarly, let's check C comma V and we'll zip star result underscore list, okay, and let's print the value of C equals C and print the V equals V, okay. So let's run it. So you can see the value of C and the value of V.